Hi everyone, today we're going to be taking notes on section 3.5 and that is called implicit differentiation. Implicit differentiation. And it's like a method of finding a derivative where you don't have to solve for y. So some functions are defined explicitly. Okay, so explicit means explicitly defined functions are where you have y equals and then everything else on this side is x. You don't have a combination of x's and y's. So we say that y is defined explicitly using x. Some functions you can't implicitly defined. For example, no, it's not two y's, defined. For example, if I have x squared plus 6xy plus y cubed equals 10. So this is implicitly defined because the x's and the y's are kind of mixed with each other, and no matter how much you try, you will not be able to solve for y in this problem. You won't be able to get it to say y equals blah 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 all in terms of x. So for problems like this, we need to still be able to find the derivative, and so there's this method called implicit differentiation. So I'm going to explain to you how that works. Let me do an example. For example, I've got the function x squared plus y squared equals 25. Now this is not the most difficult problem to solve for y. You could totally solve for y and get y equals the square root of 25 minus x squared. If you solve for y, that's what you'll get. And I think everyone knows that the graph of x squared plus y squared equals 25 is a circle. So it looks like that with a radius of 5, right? What's the graph of this? Well, it's also a circle, except if you split this function into its positive component minus, oops, I meant to say minus x squared, and into its negative component, so it's really two functions in one, a positive and a negative, then what you have is the top half of a circle, and then what you have is the bottom half of a circle. So together they make a full circle, this one and this one. But you would have to have both. So imagine if I asked you to find the derivative of this, then you'd have to split it into two different ones. You'd have to do the derivative of the positive square root function, and then you'd have to do the derivative of a square root. That involves fractional exponents, chain rule, all that stuff. So we don't want to do the derivative in that way. We want to keep it as one single function instead of two. So we use implicit differentiation. Okay, so let me write the function over again here. And in implicit differentiation, basically all you're doing is you're finding the derivative of every variable there you can see. And if you have a y, you're assuming that y is your unknown entity, and chain rule always dictates do times the derivative of the inside. So we're going to be adding in a times y prime anytime we do the derivative with respect to y. All right, here we go. So what's the derivative? You just work left to right as is. What's the derivative of x squared? It is 2x. Okay, so we are deriving it right now. What's the derivative of y squared? Well, same thing, 2y. But because, so there was a 1 here, 2 times 1 is 2. Y, you reduce the power to a 1, but then you do times y prime because we don't know what y is. Okay, so we're using the chain rule basically. We are not assuming we don't know what x is. X is just x, and the derivative of x is 1. So if you're thinking I didn't do the chain rule here, I actually did. It's just times 1 because that's the derivative of x. Equals the derivative of 25, which is 0. So then you solve for y prime. That's a 1, you guys. That's not a prime. That's the prime. So let's see. I'm going to move the 2x to the right side, and I'm going to get 2y prime that's multiplication, equals negative 2x. I'm going to divide by 2y on each side, and I'm going to get y prime equals negative 2x over 2y, which is negative x over y. This is y prime. And yeah, it's kind of funny because y prime has a y in it, but that's okay for implicit differentiation. So suppose this was part A of the problem, and part B says find the tangent line equation to the circle, so the circle that we're talking about, at the point 3, 4. Okay, so if you look at this graph, 1, 2, 3, 4, 5, 3, 4 is like right here. Basically, I want the equation of this tangent line. If this is 3, 4, I want the equation of that line. So what you would do is you would need an m. M is y prime, and m is going to be negative x, which is 3, over y, which is 4. Done. We're using the point 3, 4, so I'm going to use my point slope form. Y minus 4 equals negative 3/4 parentheses x minus 3. It's a done deal. You either leave it there or you change it into slope-intercept form, and you get negative 3/4 x. What is that? Plus 9/4, and then I'm going to add a 4. What's 9/4 plus 4? Is it 25/4? Gosh, I hope I'm right. Yeah, I hope so. Okay, there it is. Let's do more implicit differentiation so we get used to it. So example 2. I know. So find y prime if this is our function. X cubed plus y cubed equals 6xy. This is a classic example where it would be really hard to solve for y. Actually, it's not possible to solve for y. So you're stuck using implicit differentiation. So here we go. We're going to derive it. We're going to work left to right. Here we go. What's the derivative of x cubed? It is 3x squared plus the derivative of y cubed is 3y squared times y prime because of that chain rule. Just get used to it. Anytime you do the derivative with y in implicit differentiation, you're going to have a times y prime right after it. Equals. Now what's the derivative of 6xy? 6xy, you guys, is a product. This is a product. So in order to do the derivative of the right side, I have to use the product rule. So first term, second term. Here I go. Derivative of first is just 6. The derivative of 6x is 6. Times second function is y. I don't have to do y prime because I didn't do the derivative of the second function. I just did times second function. Plus derivative of second function. So what's the derivative of 1y? Implicitly, it's just 1 y prime. The derivative of y is y prime, right? Y and y prime times the first function. All right, once I have it all spelled out, it's time to solve for y prime. I like to get every term that's got a y prime in it on one side of the equal sign. So I'm going to move everything to the left. I'm going to keep 3y squared y prime on the left. I'm going to subtract 6xy prime to the left. I'm going to keep this 6y where it is, and then I'm going to subtract 3x onto the other side. 3x squared, sorry. Now I get to factor out a y prime. Factor out a y prime, leaving me with 3y squared minus 6x equals 6y minus 3x squared. And so y prime, basically I'm going to divide both sides by 3y squared minus 6x. 3y squared minus 6x is 6y minus 3x squared over 3y squared minus 6x. I notice that everything is divisible by a 3. So if I factor out a 3, I get the following expression. So here's my derivative. There it is. This is y prime. And I'm done with the problem. Let's do another one. Let's see. Oh, I know. So here's a great problem. Again, find y prime. And the equation we're talking about is the following. X times e to the y equals x plus 2y. All right, so here we go. We're going to derive it left to right implicitly. We're going to notice that we have a product here. This is a product. And the product rule says, right, f prime g plus g prime f. Here we go. So we're going to do the derivative of the first. The derivative of x is just 1 times the second, so e to the y, plus, be very careful, the derivative of e to the y is itself, but then we do it times y prime because we're doing the derivative of y, which is 1 y prime, times f, which is just x, equals, now I'm here, the derivative of x is 1, plus, what's the derivative of 2y? It's just 2 followed by a y prime. All right, now gather up all the terms with a y prime on one side of the equal sign. I'm going to move them both to the left. So this one's already on the left. It's x, y, x. Oh, I don't like that order. I'm going to write x first, then e to the y. I like to write y prime last. I'm going to subtract this one to the left, 2y prime equals, I'm leaving this one on the right side and I'm going to subtract this to the right side. All right, I'm going to factor out a y prime, leaving me with x e raised to the y minus 2. And then the last step is to divide both sides by this expression. So y prime is going to equal 1 minus e to the y power all over x e to the y power minus 2. And I don't think you can do anything, you just leave it there. Let's see. Okay, let's do 2 more implicit here. Example 4. Example 4. Where's my example 4? Here it is. So 3x squared plus xy minus y cubed equals 4. All right, we're going to find y prime again. Here we go. Left to right, what's the derivative of 3x squared? It is 6x plus. What's the derivative of xy? Well, we're going to do it using the product rule, right? Because x times y is a product. So if I want their derivative, I have to do the product rule here. So the product rule right here, okay, derivative of first is 1 times second plus derivative of second. What's the derivative of y? It is y prime times first. I just finished this piece. Now minus, what's the derivative of y to the third? It is 3y squared times y prime equals the derivative of 4, which is 0. Okay, gather up everything with a y prime together. So x y prime, I've got minus, it's on the same side of the equal sign, so I just leave it there. I'm going to move these two to that side, so minus 6x minus 1y. I'm going to factor out a y prime, leaving me with x minus 3y squared equals negative 6x minus y. My final answer is going to be basically this divided by this. You're dividing both sides by this equation. Negative 6x minus y over x minus 3y squared. Done. Okay, I want to do one more implicit, and it has to do with trig. Where is my trig equation? So here's one. So find y prime. The sine of x plus y is equal to y. All right, well, let's do this. First of all, left to right, what's the derivative of sine? It is just cosine of the same argument. Chain rule dictates times the derivative of the argument. So this argument is x plus y. What is its derivative? In parentheses, it's derivative of x, which is 1, plus the derivative of y, which is y prime, equals the derivative of y, which is y prime. Now, this is really times the cosine. So if I rearrange it, no, I don't want to rearrange it. If I know that this is one term, I get to distribute it into the following and get cosine x plus y times 1, which is just cosine x plus y, plus this times y prime, so I get y prime cosine x plus y equals y prime. How would I continue to solve for y prime? I need to get the y primes on one side. So maybe actually I'll just move this term. I'll subtract it to the left and get cosine of x plus y is equal to y prime minus y prime cosine x plus y. Factor out a y prime, leaving you with 1 minus cosine of x plus y equals cosine x plus y. And the final answer is going to be when you divide both sides by 1 minus cosine x plus y. So y prime is going to equal cosine x plus y over 1 minus cosine x plus y. That's your derivative. Okay, so to finish the notes, I have to talk to you about another piece in section 3.5 called the inverse trig derivatives. So derivatives of the inverse trig functions. Okay, the inverse trig functions. So there are 6 of them. There are 6 inverse trig functions. I'm going to make you memorize only 3. I don't really, not that I don't care, but it's not very important to memorize the inverse trig derivatives for cosecant, secant, and cotangent. But you have to memorize that the derivative of the inverse sine function is 1 over rad 1 minus x squared. You have to memorize that the derivative, this means derivative of, the inverse cosine function is negative 1 over rad 1 minus x squared. And you have to memorize that the derivative of the inverse tangent function is 1 over 1 plus x squared. So let me do an example of each. Here we go. Find y prime. Find the derivative. If the function is y equals the inverse sine of 4x. All right. So this is the argument, okay? This is the argument. Argument goes here. Argument goes here. Argument goes here. Please note our argument. Please don't forget chain rule, because chain rule says after you do the derivative, it's times the derivative of the argument. So here we go. The derivative is, I'm following this formula, is going to be 1 over rad 1 minus argument squared, 4x squared. Do you see that? Parentheses 4x squared times, chain rule is going to kick in, derivative of argument. What's the derivative of 4x? It is 4. So here's my final answer. 4 over, so 1 times 4 is 4, rad 1 minus 16x squared, and you just leave it. You are done. 2. Find y prime if you have inverse tangent of rad x. Please look at your argument. Oops, that's not supposed to be y prime, just y. So what's the derivative? Well, let's follow this formula. The derivative of inverse tangents is going to be 1 over 1 plus, it says argument squared. Argument squared. Don't forget chain rule, which says times the derivative of the argument. So what's the derivative of rad x? If you know that rad x is x to the half. So what's the derivative? It's 1/2 x to the minus 1 to the degree negative 1/2. Here's my final answer. It is 1 over. I have 1 plus rad x squared is just x. Times, there's a 2, and I have a x to the half in the bottom of the fraction, or x to the half, or rad x, excuse me. Final answer, 2 rad x times 1 plus x on the bottom. So 1 over 2 rad x over, 1 over 2 rad x times 1 plus x. Okay, and then the final problem is if I have y equals x times inverse cosine of 2x, and you need y prime, guess what rule you have to use? Product rule. There's a product. So product rule says if this is f and this is g, product rule says f prime g plus g prime f. Here we go. Derivative of f, derivative of x is 1 times g, so you just write inverse cosine of 2x, plus, what's the derivative of inverse cosine of 2x? Well, look, it's negative 1 over rad 1 minus, it says argument squared, 2x squared, times derivative of argument. What's the derivative of 2x? It's 2. I just finished g prime, and now I have to do times f, which is just x. Okay, here's my answer. Inverse cosine of 2x looks like it's going to be minus 2x over rad 1 minus, what's 2x quantity squared? 4x squared is done. This is the derivative.